Welcome to video 3 of our Relational Data with dplyr video series. You should have now completed talking about keys and the exercises that go with that, and the mutating joins, and completed the exercises that were assigned for that portion. We're now going to talk about filtering joins, where we're going to filter observations from one tibble based on whether they match in another. The first one we're going to talk about is the semi-join. And this will have the syntax semi-join X and Y, or if I am piping it in, I could pipe in the left-hand side to semi-join with Y. Now, this will keep the observations that have a match in the other one. So for instance, I could do something like, I might want to use this, say, for picking out the top destinations. So here I have taken all my flights and counted which destinations they're going through and sorted it and taken the top 10 and saved that in top destinations. So now I know these are the airports that are most frequently flown to out of the New York City area. Now, if I wanted to just save those flights, just look at those flights, then I could take my flights and semi-join it to top destinations. And you'll see now the destinations that I have are all in this list. So for instance, the first one is Miami. Yes, that's in my list. Atlanta. Yes, that's in my list, and so forth. So again, the semi-join kept all the observations in the left-hand side that have a match in the right-hand side. Now sometimes I want to do exactly the opposite of that and drop any observations that have a match in Y. This is good for finding if I have items missing. So for instance, I could look at flights that did not have a match in my planes data set by tail number. Okay, so this has given me all the ones that were in my flights data set that were not in the tail numbers. So then I can look at all these tail numbers and see, was there anything in common, what's going on there, and I find this interesting thing going on. I've got all these tail numbers that came up with an NA. So a lot of times this gives me information that I can then use to try to understand my data better. So, for instance, I can look at those flights that had an NA for the tail number and say, ooh, it looks like they all had a departure time of NA, but at least that's what it's looking like, but there's like 2,500 and something of them. So to find that out, I could try, okay, let's see if there's any of those that had an NA for the tail number that did not have an NA for departure time. And I find there were none of those. So here's a way to see that basically they put the NA for the tail number when the flight was canceled. I'm now going to show you a way to do a map. So here I'm going to join my flights with airports. And I'm going to say, okay, this is my by. Maybe I should put that in here. By equals. So I'm in the airports, it's called FAA, but in the flights data set, it's called DEST for destination. So this still is the airport that I'm flying to. But I'm going to join those because in my airports data set, there was the latitude and longitude. And then I am going to ggplot from the lat and long that I just added, adding the border of states and doing a quick map. So you can see this is a way that you can put all the destinations on a map of the U.S. For exercise 5, you are going to compute the average delay by destination, and then you're going to join on the airport's data frame to show the spatial distribution of the delays. So we're going to use either the size or the color or both to display the average delay for each airport. So work on that and come back for the last video.